Hi, good afternoon, everyone. Please let me know who all are there. Yes, good afternoon. Hello. Krishna is there. Anand. Good afternoon, Anand. Good afternoon, Krishna. So this is the first part of hydrology and irrigation. We'll be having one more part. So within that 4 hours, we are going to finish hydrology and irrigation. That is the agenda behind this session, the GATE score booster session from the GATE Academy. What we are going today, we are going to discuss a few number of questions, and using those questions, by explaining those questions, we are going to cover the entire subject of hydrology and irrigation. Obviously, it's not that much easy to finish the entire syllabus of irrigation and hydrology, but we'll finish all the important topics for sure. Apart from that, definitely some topics which can appear in the GATE examination, that also we are going to finish. Okay, so that is the agenda behind this session. We have already met with the transportation engineering before, and this session is for irrigation and hydrology. One more part is there for transportation. Just subscribe the channel and stay tuned. You will be getting the third part soon. Okay, so Gursaj is there. Good afternoon. Shankar Babu, good afternoon. I'm unable to read all the names. Sorry. Okay. Yes, I think more students has to be joined. Meanwhile, we can just give an introduction regarding this subject. Okay. So here, actually, we know hydrology is a subject, irrigation is a separate subject, right? But here for GATE examination preparation, we are just combining it. Okay, we are just combining it and studying. Why? Because majority of the portions that we are going to study under hydrology is actually what we can tell, the application of hydrology will come in irrigation, where we are going to study regarding the hydrologic structures and all. Okay, that's why we are simply combining it and studying it. If you are comparing hydrology and irrigation, we can say hydrology is having more topics to study, and there is high chance of asking question from hydrology portion compared to irrigation portion. Doesn't mean that you can skip irrigation, because recently also they have asked more questions from irrigation which are very easy to answer. Okay, so that is first point which I have to tell you. When I was preparing also, since the weightage of irrigation is less, many students skip that subject. But what actually happens is, easily you can score from irrigation. So if you are simply skipping, you are actually going to miss some easily scoring questions which you are unable to answer it, right? So just have a look into this session. Within this 4-hour session, we'll be having 2 hour today and 2 hour tomorrow, part 2. So within this 4-hour session, if you are properly attending it and properly going through the session and solving some questions, definitely you are going to attend those questions which are going to coming in the examination. Okay, so I think we can start, right, without wasting much time. Hi, good afternoon. Kushbu, Mansi. I'm sorry, I'm unable to read all the names. Sayandan, Swaroop, Mudgil. Yeah, good afternoon, everyone. So first, I'm just giving you an introduction regarding the hydrology and irrigation syllabus. Okay, just if you are splitting it to hydrology and irrigation, under hydrology we have to study regarding precipitation, very important for GATE examination. Under precipitation we have to study these many topics. I'm just giving very important topics only here. Meanwhile, whenever we are discussing, definitely we'll discuss some other topics also. Okay, optimum number of rain gauge stations we have to study. We are going to do questions. Okay, for all these things we are going to do questions also. Then estimation of missing data, that is in case if the rainfall data is missing, means we are going to measure the rainfall data. In case if any instrument has missed the rainfall data to record, we are going to estimate that missing rainfall data, that we are going to study. Then how to calculate the average rainfall data over a particular area, that also we are going to study. Then probability of rainfall, we have studied the probability in transportation engineering also, maybe in mathematics also you might be studying. Here also we have to study high chance of asking MSQ type of questions in this probability of rainfall. We are going to do MSQ on this particular topic also. And hyetograph and mass curve, that also we have to see, may be asked for 1 mark and can be asked for 2 marks also. So these are the very important topics under precipitation. Okay. Then coming to the next chapter, evaporation and transpiration. These are the main topics that we are going to cover. In this, the first two, the measurement of evaporation and measurement by water budget method. These two are very important for examination. Repeatedly asking the other topics such as measurement of evaporation by energy balance method, control of evaporation. These are comparatively unimportant, but anytime they can ask. So I'll just give some points regarding those things. Then evapotranspiration can be asked for theory, like 1 mark question, or for column A, column B matching purpose. They can ask evapotranspiration also. That also we are going to discuss. Okay. Then coming to infiltration and runoff. See, I'm just giving a basic introduction so that once you have prepared, you can just go through this portion and just check whether you studied this point, this point, this point, like that. Okay. Horton's infiltration curve, very, very important for gate examination. Similarly, phi index, W index, that is also very important. Then calculation of runoff. It is a subtopic of Horton's infiltration curve and all. That also repeatedly asking for 2 marks that we are going to see, okay, through questions. Then coming to hydrograph, I can tell which is the most important chapter in hydrology. Simply hydrograph. Sometimes they may ask from other chapters, okay. Flood hydrograph, direct runoff hydrograph, unit hydrograph. These three things are the topics that we are going to study. And the other topics which I have written are the applications of unit hydrograph. We are going to see each and everything, method of superposition, when we are going to use this, how to approach a question. That is very important in hydrograph. Whenever you are seeing a question, you should decide in which way I have to proceed. That is very, very important in hydrograph. That's what most of the students, the mistakes most of the students are making in the examination hall. You have to decide, or you have to understand how to approach a question. Very important in hydrograph, that we are going to discuss. Okay. Then coming to well hydraulics is nothing but, sometimes you might have studied some portion of well hydraulics in geotechnical engineering also. Regarding aquifer, we have to study, and aquifer can be unconfined or confined, that we are going to study. And in a comparatively less important topic, recuperation test, but that also we will discuss. There is a chance of asking 1 mark or 2 mark question from there also. Then coming to some miscellaneous topics, not that much important, but some portions under this flood routing, especially Muskingum method and all, repeatedly asking for 1 mark in competitive exams. Gate exam also they have asked. We'll do some numerical also under this flood routing. And regarding maximum flood estimation and river gauging, we'll discuss a few points which can appear in the gate examination. Okay. So these are the portions, or these are the topics we have to study very importantly under hydrology. And then the irrigation, I have not written the subtopics here. Irrigation, definitely that we are going to cover in the next session, part 2, which is going to happen tomorrow on the same time. And then I will discuss what are the things which we are going to study under irrigation. Okay. In today's session, we will try to cover as many as possible under under hydrology. We may finish with hydrograph only, because so many topics have to be studied under hydrology, that one by one we will study. Okay. And finally, at the end of the session, definitely you will be in a position to solve whatever questions they are going to ask in the examination. Okay. So I hope you got a rough idea regarding hydrology portion. Then directly we can go to the first topic, nothing but optimum number of rain gauges. So just read the question. More students have joined. Good afternoon, everyone. So just read the question first of all and understand what they have asked. Definitely, I will explain something. Meanwhile, those who have prepared, you can just go through the question and just start solving it. I will give you some 30 seconds maybe. Then I will start explaining what are the things you have to study under optimum number of rain gauges. Okay. Okay, yes, hydrology and irrigation are important. Easily scoring subject, that is, we don't have to spend a lot of time to study hydrology and irrigation. Okay, that is the best thing. If you are comparing the weightage, obviously combined irrigation plus hydrology, you will be having around 5-mark weightage on an average. So if you are comparing with transportation, geotech, environment, then obviously weightage is less. But the effort that you are going to put to get this 5-mark, if you are comparing with this high weightage subject, that will be very, very less. Okay, so you just attend the 2 parts, 2 sessions. Definitely at least 90% of the questions you can solve. Okay. So if you have any problem with the font size and all, you can just let me know if anyone is watching in mobile. Right. So I hope you have gone through it. No need to write the entire question. Just take down the data. Later, definitely, once the subject is finished, we are going to give you the PDF of the questions and all. Don't worry. Yes, I hope you have gone through it. Now I am just giving a data. First of all, what we need to remember, the concept optimum number of rain gauge stations. First of all, understand what you mean by this rain gauge. Nothing but the instrument that we are using to measure the rainfall data. There are so many names for this rain gauge. We call it as ombrometer. We'll call it as pluviometer. We'll also call it as hyetometer. So there are so many names for this rain gauge, which is nothing but the instrument which we are using to measure the rainfall. Okay. There is another instrument, hygrometer. Hygrometer is for humidity. Okay, GRO. Hygrometer. Hyetometer. We are going to study regarding hyetograph. Then I will tell these points again. Okay. So the rain gauge is nothing but the instrument which we are going to use to measure the rainfall data. So if we have some particular number of rain gauges in the catchment, we can also call it as rain gauge stations. Okay. And we need some particular accuracy for the measurement. Then we can check whether we have sufficient number of rain gauge or not. Okay. We can check whether there are sufficient number of rain gauge or not. So how can we calculate that? To check the sufficient number of rain gauge, we can also call it as optimum number of rain gauges. So optimum number of rain gauges N is equal to CV divided by E whole square. Very, very important equation. The CV stands for coefficient of variation. Sometimes in the question directly give that, sometimes they will give some data. From the data we have to calculate the coefficient of variation CV. How can we calculate CV? The equation is very simple, 100 into sigma divided by P bar. Sigma stands for standard deviation of the data. P bar stands for the mean rainfall depth. So as I told you, either there are 3 cases. One case they will directly give you the coefficient of variation CV value, or they will give you standard deviation and average precipitation P bar, or they will simply give you some rainfall data like this question, from where we have to calculate P bar and sigma. Okay, where sigma is the standard deviation. We are going to calculate these things. Okay, and P bar stands for mean rainfall or average rainfall data. E is nothing but the percentage error. Percentage error actually stands for the acceptable error, in the sense, for example, if I am taking in this question, you can see they have written that 90% accuracy is required, which means, what is the meaning that 90% accuracy is required? How much error is okay for us? Obviously 10% error is okay for us. That is the meaning of error. Okay, so one thing we can easily substitute here, E is equal to 10, right? So our task is to calculate what is the CV value first of all. How can we calculate CV? First of all, we need to calculate P bar. How to calculate P bar? Do it fast. 10 plus 12 plus whatever they are giving, simply take the arithmetic mean. How much will be the P bar? Yes, very good. How much will be P bar? If you are adding all the things divided by 5, how much you are getting? So sigma given value of P divided by N. 13, right? Please reply everyone. Yes, very good. 13 centimeter. Okay. How can we calculate standard deviation? Yes, very good. Thank you for commenting. How can we calculate standard deviation? Yes, P1 divided by P bar the whole square. Basics, you should remember the basics. Then P2 divided minus P bar the whole square, etc. You do everything. The very important thing here, divided by N minus 1. Okay, that is the portion everyone used to make mistake. So if you are doing, how you will be getting the data? Please solve and tell me how much you are getting sigma value. 10 minus 3 will be 3. So 3 square. So here it will be 3 square plus, like this we have to substitute. Then 12, 16. So 2 minus 13 minus 1 square. So I'm putting 1 square. Okay. It's simply the positive value. And so on, divided by the most important. You have to take 5 minus 1. That is the only thing you have to note down. Can you please tell me how much you are getting sigma? 2.44. Okay, thanks for replying. 2.449. Do one thing, no need to round it off. Directly you calculate. Once you are getting this value, directly you multiply with 100, then directly divided with 13. Then you can take divided by 10 there itself. Then square. No need to round off, no need to stop anywhere. Directly you can calculate. How much you are getting CV? 18.84. Thank you. Yes, very good. Now see, very important thing. Here we are already multiplying with 100, right? Here we are already multiplying with 100. So whatever we are getting is directly in percentage only. Okay. That is why whenever we are substituting, this is another point you have to note down. This is in percentage already. So the CV value whenever the error value whenever we are substituting, if it is 10%, we got it as 100% minus accuracy. Okay. So that is going to be 10% according to our question. Don't substitute 0.1 here. Okay. Substitute 10 itself. Okay. Because both the numerator and denominator should be having same unit. That is nothing but percentage. Okay. How much you are getting? Yes. Very good. Please comment everyone. What is the answer? Thank you. 3.55. Right. Now, if I am asking a question, our question is there, let it be there. If I am asking a question, what is the optimum number of rain gauges? Tell me what is that answer? What is the optimum number of rain gauges? Very good. Very good. What it is? 4. It is not 3. It is not 3.55. It should be 4. What is the meaning of this 3.55? If we need 10%, if we need 90% accuracy, or we are okay with 10% error, at least you should have 3.55 number of rain gauge. What is the meaning of 3.55 number? It is a particular rain gauge. No? So if I have only 3, it is not sufficient. I require something more than 3. So minimum we need 4 number of rain gauge station. That is the meaning. Now, if we require 4 number of rain gauge station, now what is our question? How many additional rain gauges are required? Tell me how many additional rain gauge we require. Everyone, which option you are going to select? Yes. Everyone, please comment which option you are going to select. Which option? Very good. Option D is going to be our right answer. Why option D is going to be our right answer? We require 4 number of station to have, or 4 number of rain gauges to have 90% accuracy. We already have 1 extra, which means we are going to get more accuracy practically. We are getting something more than required. So it's a positive thing for us, good thing. We don't require anything extra. Don't simply take the difference and take option A as the answer. Properly check what is optimum number and what we have. Understood? Is it clear? Direct substitution, directly substituting the values in the equation, we are going to get the data. In case I'm telling some extra point, in another question, suppose they are telling that there are 5 rain gauges present and we got optimum number is equal to maybe 8. Okay. So if they are asking how many additional number, what we require? Optimum number of rain gauge minus existing. Okay. Simply don't take the difference, properly check it. Is it clear? Understood? Few students were commenting as option A also. That's why I'm telling. Is it clear now, everyone? Yes, in this second example, it will be 3 then. Okay, understood now? Everyone clear? Please comment. Yes, very good. Understood. That is the first point. Optimum number of rain gauges. Okay. If you are getting both equal, okay, 5 rain gauge is the present data, the present number, and we are getting after calculation, we are also getting 5, which means extra is 0. Okay. If it is more or if it is equal, we don't require anything extra. Clear? Very easy thing. Don't make any mistake in the exam. Okay. So CV, what is the problem in CV? Direct substitution. 100 into sigma divided by P bar. P bar we calculated, which is the average. Okay. Nothing but 10 plus 12 plus 16 plus 15 plus 12 divided by 5. Okay. We will be getting 13. Then standard deviation equation. 13 minus 10 whole square plus 13 minus 12 whole square, like that. Since it is square, if you are taking 10 minus 13 or 13 minus 10, both are same. We'll be getting 2.449. Substituting in CV, nothing but, since I got doubt, I'm just telling 100 into 2.449 divided by 30. That's it. Is it clear now? Okay. Yes, very good. Now we are going into the next topic. Just read the question first of all and understand what they are asking in the question. Then I will explain what it is. 1 second. Please hold on 1 second. In the last problem, one more additional data I'm telling you, or one more additional concept I'm telling you. The rain gauges can be either recording type or non-recording type. Okay. Either the rain gauge can be of recording type or non-recording type. What is the meaning of this recording type and non-recording type? In the non-recording type rain gauge, we will be getting only the depth of rainfall. Finally, how much depth of rainfall we got per day or per week, like that. In recording type, it will record with respect to time. In the sense, if I have a non-recording type, let be, if I have the first type, the recording type of rain gauge, if I want to know what is the rainfall came maybe yesterday at 10 o'clock, or what is the rainfall at 12 o'clock, or what was the rainfall at 4 o'clock, like that, each time we can find the rainfall data separately. If we can find, or if we can measure the rainfall data at any particular time, then we call it as recording type. It is recording the time also. Okay. In non-recording type rain gauge, we cannot measure with respect to time. At 10 o'clock, how much rainfall? At 12 o'clock, how much rainfall? That we will not get. We will get only total in the throughout day, how much we got. That is the only value we are getting in non-recording type. Okay. Definitely recording type rain gauge will be having some complex mechanisms and all. So every time we may not be using the recording type, but at least if we have a catchment area, and for example, if I'm keeping 20 rain gauges here, out of these 20 rain gauges, at least 10% of the rain gauges should be of recording type. Understood? So that you just note down, at least 10% of the total rain gauges should be of recording type. In the sense, if we have 20 rain gauges in our catchment area, you tell me minimum out of this 20 rain gauges, minimum how many numbers should be of recording type? Everyone please comment. Minimum how many number we should have recording type? Very good, 2 numbers. And 2 should be, minimum 2 should be of recording type. The remaining can be non-recording. Is it clear? Okay, that is one simple extra point that you can remember. Okay. Yes. Now come back to this particular question. Yes. Read this and understand what they have given. Yes. Very good. All are replying. Please read this question and understand what we have to do. The question is related to some missing rainfall data calculation. Yes, very good. I'm getting the answer also. Very good. Very good. Finally, you should be getting 178 point something. Very good, Krishna. Good. Now see, those who are not getting the answer, don't worry. We are going to discuss how to do it. Okay, meanwhile, you can note down the data also. No need to write the entire question. Now listen properly. Whenever we have a missing rainfall data or some rainfall data is missing, they are asking us to estimate or what may be the data. Okay, then what we need to do, two data are required to estimate a missing rainfall. What is that? The first point is the normal annual rainfall. The normal annual rainfall. If I am denoting it as simply N, normal annual rainfall stands for the average rainfall that we have at a particular location by checking the data of last 30 to 35 years. Means along previous historical data that we are collecting, and we are checking what is the average value of rainfall per year in that particular location. That we call it as normal annual rainfall. Okay, so this is the average of last 30-35 years of historical data. So this historical data will be available, 100% sure, will be available for all the stations or for all the points. Okay, and if we are counting or if we are measuring the rainfall maybe in 2021 or 2020 in a particular year, we can simply call it as in that particular year we are going to measure the annual rainfall, okay, or mean rainfall or annual rainfall. I'm telling it as P. So this P is in a particular year, a normal N is the historical data, okay. And if we have some particular number of rain gauges, maybe the first rain gauge is A, second rain gauge is B, third rain gauge is C, and so on. Maybe if we can take the same example, we have 4 rain gauge stations according to this question, A, B, C, D. So 4 rain gauges we are keeping. In a year, we can measure the rainfall at A. We can put it as PA. This we can put it as PB. This is PC. This is PD. Similarly, the normal annual rainfall of all these rain gauges are NA, NB, NC, and D. Here, what we need to do is always these normal rainfalls will be always available for sure. In case in any year, if any value of P is missing, then using this rainfall data of normal rainfall data and other P values, we are going to estimate what is that missing rainfall. Okay. So after reading the question, can you tell me which data is missing here? Whether PA is missing, PB is missing, PC or PD. Everyone please comment which data will be missing. Everyone. Either PA or PB or PC or PD. Very good. PA is missing here, because it is given that in a particular year, station A was inoperative due to some mechanical reason. Okay. And they have given the data of PB, PC, and PD. So what are those data? 177.6, 186.5, 198.2. So these 3 rain gauges were having no problem, but this is missing. Now we are going to find this missing data using the other values. To check this, we have 2 methods. Okay, one is simple mean method, the other one is normal ratio method. Simple mean means, as the name indicates, it is the simple mean. Means PA is equal to PB plus PC plus PD divided by 3. That is the simple mean method. The next one, normal ratio method, is having another equation. So we have to check whether we can go for simple mean method or we have to do normal ratio method. That is the challenge we have. Okay, how can we calculate that? Here I am writing what is the Na value and all. 180.4, 178.2, all are in centimeter. 189.6, 199.8. Okay, now what we are going to do, whatever is the missing data or our rainfall corresponds to A is missing now. Now correspondingly we have to select the normal rainfall N value. Okay, so this 180.4 we are going to select, and we are going to calculate a range of data which is nothing but 90% of Na to 110% of Na. So what is this 90 to 110 percentage? 10% variation, 10% variation from this Na value. Clear? Nothing but 90% of Na, 110% of Na. Okay. So if you are calculating the range, how much you are getting? 0.9 into 0.9 into 180.4 will be coming as 162.36. So 162.36 to 198.44, right? So this is our range. Now what we need to do, we have to check all these other N values and check whether this is in this range or not. Okay. I'm giving so much of explanation because it is very important. For all the questions, we may not be having this much time to explain. Now check whether all the data in this range or not. First one, 178.2. Whether 178.2 is in this range? Yes. NB is in this range. Second one, 189.6. Whether it is in this range? Yes, that is also in this range. Now, if ND is also, if it is in the range, we can go for simple mean method. Check 199.8. No, it is somewhat outside the range. Henna? So this is not the range. Now, if at least one is out of the range, we cannot go for simple mean method. We have to go for normal ratio method. Understood till here? Till here it is clear. If this ND is also within this range, then we can go for simple mean method, which is nothing but PA is equal to PB plus PC plus PD divided by 3. Okay, simply average of other P values. But since it is out of the range, then what we need to do, we have to use the normal ratio method. What is that? The nothing but the missing one divided by Na. Simply you can remember like this, P by N ratio. PA by Na is equal to PB by NB plus PC by NC plus PD by ND. But since we have 3 here, PB, PC, PD, what we need to do? We need to divide with 3 or simply multiply with 1 by 3. Clear? Now we have to calculate what is PA. Now we can keep NA there and calculate. Yes, very good. Now tell me everyone. I started getting the answer. Very good. Yes, very good, very good. Krishna, Gautam, Monica, Anand, Stravani, very good. I'm sorry if I missed any name. So finally, Na you can substitute there. So 180.4 divided by 3 into, inside the bracket, we will be having 177.6 by 178.2 plus 186.5 by 189.6. So on, finally, you are going to get 178.72 centimeter. Very good, because understanding? Tripti, yes, very good. Is it clear, everyone? Clear? Now, suppose the ND value was somewhat 190. Okay, suppose the ND value was 190. Then how we are going to calculate PA? 177.6 plus 186.5 plus 198.2 divided by 3. In the calculation, we don't require N value then. Clear, everyone? Very good. So shall we go to the next topic then? So we have seen optimum number of rain gauge, then missing rainfall data. Okay, which method we have used here? Normal ratio method. Okay, right. Clear? Yes, 178.8 or 178.7, it is okay. It depends on how accurately you are doing the calculation. No need to stop anywhere. Directly you can calculate. Okay, PB minus NB equal to plus, open the bracket, Even if you're not opening, you will be getting the same answer, but you just take it, okay, in the online calculator, how it is coming. Very good. Okay. Sajid, Kushbu, very good. So shall we go to the next question? If any doubt, if you are getting, please let me know. Yes. Now take the next data, next question, which is the next topic, nothing but calculation of the average rainfall or mean rainfall. Okay. So just go through the question and understand what to do. Just understand the question, take down the data and select the proper data and calculate the answer. Just note down the data only, okay? No need to write the entire question. You can just draw the figure and just take down the data. Whenever they are asking the mean rainfall, they will be giving you either a figure or they will tell the figure in terms of sentences in the question itself. Clear? Everyone? I'm giving you some time to understand the question. I want you to think about it. Please check it and tell me how much you are getting. Or no need to solve the entire thing. Meanwhile, I will explain. 6 rainfall data we have. Okay. So do you know which method we are going to use for this? Which method we are going to use to calculate the average rainfall? We have actually 3 methods. One is nothing but the arithmetic mean method. Arithmetic mean method, nothing but one value plus the other value plus other value divided by total number, which we are actually using for optimum number of rain gauge calculation and all. Yes, very good. So here we are using the next method, Theis and polygon method. So generally they will be mentioning in the question itself using Theis and polygon method. Okay, sometimes they may not mention, but from the equation, from the question data itself, we will understand. Yes, very good. Then one more method we have, Hyetographs method. Okay, I will tell you what is this Hyetographs method and all. One example also will do for this Hyetographs. Arithmetic mean is nothing but sum of data divided by total number. Okay. Then this question is related to Theis and polygon method. So what is this Theis and polygon method? I'm simply giving an introduction. Hope you know it, or I don't want to waste so much of time. So what I will do, I will give a link for the gate booster session, score booster session, which we have done in the last year. Okay, for 2020 gate examination. There I have taken a question for the same mean precipitation calculation, where we were having not like this, like a pentagon shape. Okay, like a pentagon shape. What was the twist there? And it was catchment area. Like that, a question last year. That link will be in session up once the video is getting uploaded in this channel, or you can simply search in YouTube Gate Score Booster Session, the Gate Academy. You will be getting the data in the, you will be getting the link in the YouTube. Okay. There I have explained the each and every step of Theis and polygon method. You can just refer that for more explanation. Properly listen, everyone. If it was a regular hexagon, what is the meaning of regular hexagon? If we have, okay, for example, simply I'm telling you, if we have an equilateral triangle, okay, simply one basic explanation. If we have an equilateral triangle with all sides equal, do you know what is the area of an equilateral triangle? Root 3 by 4 a square. Okay, equilateral triangle area is nothing but root 3 by 4 a square. You can also calculate it by drawing a perpendicular here, and you can calculate what is this height. Then if you are doing half BH, finally you will be getting root 3 by 4 a square. Now if we have a particular, if we have 3 rain gauges here in the corner, sorry, if we are doing Tyson polygon method, what we are actually doing, we are going to draw perpendicular bisectors for each of these lines. Whatever be the number of rain gauges, that many polygons we are going to get. Here, if you have 3 rain gauges, then one area, one polygon will be get here, and another polygon will be getting here, and the next polygon will be getting here. Like that, whatever be the number of rain gauges, that many polygons we are going to get. If it is an equilateral triangle, each area will be 1/3 of this total area. Nothing but 1/3 of root 3 by 4 a square. That is for an equilateral triangle. Similarly, if it is a square, we are going to get 4 equal parts. That will be 1/4 of the total area, each polygon. This explanation I have done in detail in the last year video. If you want more explanation, you can just watch that. Okay. Now, if we have regular shapes, for example, if you have a regular pentagon or regular hexagon, for example, see, if you have a regular hexagon, what is the meaning of regular hexagon? All the sides will be equal. All the sides will be equal. All the angles also will be equal. Can you tell me what will be the angle of a regular hexagon? What will be the angle of a regular hexagon? Everyone, please comment. If it is a regular hexagon, what will be the angle? Internal angle. Everyone, please comment. All sides will be equal. Is it 60 or is it 120? Everyone. If it is a regular hexagon, remember definitely it is going to be more than 90. Look at the shape. Is it 60 or 120? Everyone? Yes, 120 degree, na? It's going to be more than 90 degree. Obviously, from the shape, what you are understanding? See, till here itself, it is 90. Okay, 90 plus 30 it will be. Understanding? If it is a regular hexagon, then all the angles will be 120. Now see this question. Is it a regular hexagon? Is it a regular hexagon? Obviously not. Why we need to check whether it is a regular hexagon or not? If it is a regular shape like this, for an equilateral triangle, all the 3 sides are equal and all the angles are also will be equal, which is equal to 60 degree. Okay, 60, 60, 60. Similarly, if it is a square, all the sides will be equal and all the angle are going to be 90 degree. Similarly, if it is a hexagon, all sides will be equal, all the angles will be 120 degree. And why we need to check whether it is a regular hexagon or equilateral triangle or square or rectangle and all? For an equilateral triangle, all the polygons will be 1/3 of the total area. Similarly, for a square or rectangle, all the polygons or 4 polygons that we are getting will be 1/4 of the total area. Similarly, if it is a regular hexagon, all the polygons, how many polygons we are going to get? If it is a regular hexagon, everyone please comment. If we have one rain gauge here, 2, 3, 4, 5, 6. If it is a regular hexagon, please tell me how many polygonal area we are going to get. Very good. 6 polygons we are going to get. Number of polygons will be equal to, Tyson polygon, okay? Number of Tyson polygons will be equal to, see like this we are going to get. Number of Tyson polygons will be equal to number of rain gauges. So 1, 2, 3, 4, 5, 6. And all the areas will be equal. A1 equal to etc. equal to A6. That will be 1/6 of the total area. Why we need this? To calculate the weightages. All weightage will be equal to 1/6. I hope you know what is Tyson weightage and all. Area of a particular polygon divided by total area. Okay. I hope you know that. In case if you don't know, I already told you. In the last year video, I have given much explanation. Okay. Lot of explanation. You can just watch that so that we can make use of that time to solve more number of questions and more topics. Okay, we can do a complete revision of hydrology and irrigation. Clear? Now see, is this a regular hexagon now? Tell me. Is this a regular hexagon? Everyone, can I take the polygon, all polygonal area equal to or equal, and can I take 1/6? Obviously not, because the angles are different. है ना? Here, how many polygonal area we will be getting? Yes, very good. Can you split this portion into 3 different portion? See, in the classroom or in the video or at present we may take some time, but in the gate examination hall, we are not going to waste our time. If it is a regular hexagon, we are directly going to take each polygonal area equal to 1/6 of the total area. And if they are giving 60, 150, 150, 60, 150, 150, don't waste your time. What we can do? Yes, very good. In the examination hall, don't waste your time. Just split it into 3 shapes. Then what we are going to get? One equilateral triangle we will be getting on the left hand side. Yes, very good. One equilateral triangle you are going to get on the right hand side. Then a square you are going to get it in the middle. What will be this angle? 60 degree. 90 plus 60. This is also 60. This part is also 60. This part is also 60. So this can be another twist which they are going to give. Instead of giving a regular hexagon, they can give something like this. Clear? Okay. So how to split an equilateral triangle that we know? That will be coming into 3 parts. The right hand side also coming into 3 parts. Center portion will come into 4 parts. Yes. So can you split that? Can you split that? How to draw? How to draw the Thiessen polygonal areas? How to take Thiessen polygonal area? It will not come. The dimension which I am drawing will be having little bit difference. How to draw it? This is how we are having. How to draw the Thiessen polygons? What are the steps? Just draw the perpendicular bisectors to all these lines. So we are just matching, or we are just combining all of this, and we are going to draw Thiessen polygons. So we are going to finally get something like this. So you draw properly on the notebook, it will be easier to draw. Yes. So are you getting something like this? Right? So tell me how many polygonal area you should be getting. 1 rain gauge here, 2, 3, 4, 5, 6. Tell me how many polygonal areas I should select. Everyone please comment how many polygonal area we should select. Very good. 6 polygonal areas. So how we are going to select it? Definitely this is for this guy. This portion is for the second one. Then these many portions will be for the third one, and so on. Finally, how we are going to get? Everyone please draw it. I have just made a figure for your better understanding. So are you going to get something like this? Everyone? Are you going to get something like this? Just for your understanding, I have just colored and all. Clear? Yes. So if you are simply naming it as how they have given the name A, B, C, D in the clockwise direction. So this is the area corresponds to A. This is the area corresponds to B, AC, AD, AE, and AF. Clear, everyone? Is it clear? Yes, very good. So what will be the area AA? AA and AD will be equal, na? AA and AD will be equal. That will be what? 1/3 of that triangular area. If we are selecting that triangular area, so what is one side? They have given in the question that each side is 10 kilometer. So each side is 10. This is 10. This is 10. All are 10. So once we are getting 60, 60, 60 as angle, which means this side also will be 10 kilometer square. Sorry, kilometer. Okay. So that is 1/3 of area of equilateral triangle. So what will be that? 1/3 of root 3 by 4 a square. A is nothing but side of the triangle 10. Enough? So tell me how much you are getting. AA and AD are equal. Na? Tell me how much is that data? How much is that area? Yes, very good. 14.43. Enough? That particular area. 14.43. So we have two areas of 14.43 kilometers square. One is this AA and one is this AD. Enough? Yes, thank you. Now what about AB, AC, AE and AF? Will it be equal or different? All these areas are going to be equal. Na? AB, AC, AE and AF will be equal. What will be that? See, 1/3 of this triangular portion plus 1/4 of the square. Enough? So 1/3 of area of triangle plus 1/4 of square. Enough? Clear? So that part, this much portion we already calculated, which is 14.43 kilometers square. Then what will be 1/4 of the square? 10 into 10. Enough? So 25 plus 14.43. How much you are getting? Everyone please comment. 25 plus 14.43 will be around 39 something. Thank you. 39.43 kilometers square. Is it clear? Is it clear, everyone? Krishna will come to the answer. Clear, everyone? All are getting the same? All area will be same. 39.43. Very good. Very good. Okay. Hope all are getting. Now it's very simple. We got all the area. Now what we require? According to Thiessen polygon method, what is our equation? P average is equal to P1 A1 plus P2 A2 plus etc. Whatever be the rain gauges we have, if it is n, then P n AN divided by total area. Total area is nothing but sum of all these Thiessen polygonal areas. Here we have named A, B, C, D and all. So properly, this is the next point you have to take care. Corresponding to A, what is the value of precipitation? It is 12 centimeter. So that properly you have to check. Corresponding rainfalls you have to take. So the rain gauge A is having 12 centimeter. The Thiessen polygon area of rain gauge A is, what is rain gauge A? 14.43. So how we have to substitute the value? Corresponds to it is 12 centimeter. So 12 centimeter into 14.43 kilometers square plus what is PB? See, either you can write PB there or you can just combine 12 also this D, na? What is D? A, B, C, D. So 6.8. Rain gauge A is having 12 centimeter, rain gauge D is having 6.8 centimeter. Both are having same area 14.43. So directly you can do 12 plus 10.2 multiply with 14.43 plus the remaining area 39.43 into the sum of remaining P value. Okay, if I'm simply writing in the general sense, next one is 14 centimeter. So 14 centimeter multiply with 39.43 plus etc. All the things you have to write, whole divided by, you just add all the area. Square we have root 3 by 4 into 10 square, root 3 by 4 a square. So like that, two areas we are having plus we have a square of 10 kilometers side. Okay, so either you can do like this, total area, or 14.43 into 2 plus 39.43. We have 4 pieces. Sorry, yes, 4 pieces we have. Enough? How much you are getting? Yes, please everyone, please comment how much you are getting. Everyone calculate and tell me the final answer. 10 point, very good Krishna, 10.54 is the right answer. Very good. Okay, approximately if you are getting 10.5, that is correct. It depends on how accurately you are taking the data. Even this 10, if whatever I have written is also not accurately correct now, because it 10.433 something you may be getting. Depends on how you are rounding off. 10.5 if you are getting, your answer is correct. Okay, question I have given in centimeter, round off to 1 decimal. That is very important. Sometimes to mislead you, they will be giving and all. Properly check what is given here. All are in centimeter. So your calculated value is in centimeter. So 10.5 is in centimeter already. Round off to 1 decimal. So they may give some data 10.1 to 10.9, something like that. Okay, or maybe some 9.1 to 11.9, something they can give. Don't expect a big range. Okay, since a lot of calculation are getting approximately 10.5, 10.53, 10.55, everything is fine. Is it clear, guys? Okay, for more explanation, you can just watch the last year video. One more extra point I can tell you. See here, we have already mentioned, I have already mentioned extra point, okay? For a regular hexagon, okay? For a regular hexagon, I told you, in case if they are giving a regular hexagon, we know all the data, A1, A2, etc. All the data are equal to 1/6 of the total area. You know? 1/6 of total area. Now we don't have to calculate those areas. You know? This P1, A1, what is this actually? This A1 by total area, we can rewrite it as P1 W1 plus P2 W2, etc. Where W1, W2, etc. stands for phase and weightages. Nothing but A1 by total area is W1, A2 by total area is W2, etc. If you are adding all those things, what we will be getting? A1 by total area plus A2 by total area, etc. What is that? W1 extra point, okay? Sum of W1, W2, etc. Wn. Tell me how much it will be, everyone? Very good, very good. It is equal to 1. That also can be a 1 mark question, theoretical. Or simply see what they can do. They can give any figure and 3 weightages they can give. The 4th weightage they may not give. Or 3 area they can give. The 4th area they may not give. Then what we can do, if there are total 4 area, the sum of phase and weightages will be equal to 1. So from there you can calculate the 4th one. Is it clear, everyone? Okay, the sum of values will be, sum of weightages will be equal. From the equation also it is very clear. Clear enough? Yes. So that point you note down. Now if they are giving a regular hexagon, either they can mention that it is a regular hexagon in the question. See, suppose like this. In the question, what they can do, they can give here in the form of a regular hexagon. Then they will not give the figure. Then the figure will not be like this. Then the figure will be 120, 120, 120 and all. Understood? So once they are giving like this, it's a regular hexagon. Then no need to calculate the area at all. Whatever be the side they are giving, no need to calculate the area and waste your time. Directly, if they are giving a regular hexagon, what we can do? P1 into W1 will be 1 by 6 plus P2 into W2 will be 1 by 6 plus etc. plus the final value P6 into 1 by 6. So directly like this you can calculate. Clear? Everyone? Everyone, is it clear? Now one more extra point I am telling you. Suppose they are giving you a regular hexagon and they are giving an extra, one second, if they are giving one extra rain gauge, nothing but a 7th rain gauge at the center. Now can I take all the rain gauge, all the area will be equal, and can I take it is equal to W1 equal to W8 equal to W7. Can I take that is equal to 1 by 7? Can I take, if they are giving a 7th extra rain gauge at the center, can I take it as equal to 1 by 7 everywhere? If this is 1, 2, 3, 4, 5, 6, 7. Is it correct or wrong? Very good. It's absolutely wrong. We cannot take like this. Note down that. You can just practice and you can just check how the polygonal areas are coming. Actually, we will be getting 18 equal pieces. Okay, 18 equal pieces we are going to get. And just you can just directly remember A1, A2, etc. A6. Till A6, definitely it will be equal. And that will be equal to, I told you, there will be total 18 pieces. All these areas will be 2 pieces out of this 18 pieces. That is equal to 1 by 9 of the total area. You can just remember this, or you can just practice later and you can just make sure you are getting this. In the sense, what is the meaning of this? W1, W2 equal to W6 will be equal to 1 by 9. And what is the remaining? What is remaining? 2 pieces out of 18 pieces for all the area. Means something like this we are going to get. You can just practice later. Okay. I'm not drawing anything. So 2 pieces for each area. So 6 pieces will be having then 12 pieces already completed. Remaining there will be 6 pieces. So 6 by 18. Nothing but 1 by 3. So in case if they are giving a regular hexagon with the 6 rain gauges, you can directly take 1 by 6, 1 by 6 everything. If they are giving a 7th rain gauge on a regular hexagon, for all the 6 rain gauges, you can take 1 by 9 as weightages, and inside you will be getting 1 by 3. You can just check what is the sum of weightages. 1 by 9. Similarly, we have 6 pieces, nothing but 6 by 9 plus 1 by 3. If you are getting calculating, you will be getting 6 by 9 plus 1 by 3 is nothing but 1 you are going to get. Nothing but 2 by 18 plus 6 by 18. Okay, not 2 by 18 plus 2 by 18 into 6, 12 by 18 plus 6 by 18. Okay, is it clear, everyone? Okay. Yes. Clear now? Just note down as an extra point. For this question, we don't require. Please, everyone, comment. Is it clear till here or not? Yes. Very good. Okay. Right. So, hope all are getting the answer. Yes. So, shall we go to the next question then? Yes. So, take this question now. As I already told you, there is high chance or high possibility for asking an MSQ in this probability of rainfall. If the examination question setter wants to make a MSQ, very easy to make an MSQ from probability concept. So just read the question first of all and understand what is given. Only one data is given. A flood of certain intensity is expected to occur once in 25 years. What is the meaning of this 25? What is the meaning of that sentence? A rainfall or a flood or anything, tsunami or anything is expected to occur in 25 years. Means what? What is equal to 25 years? Everyone, please comment. Very good. Frequency or return period. We used to denote it by capital T. Just remember other names of return period. Either we call it as frequency, or we call it as return period, or we call it as recurrence interval that you can see in the first option. Recurrence interval is another name of frequency or time period. Okay. So from the question data itself, what you are understanding, whether the first option is correct or not? Obviously, option A is wrong, because recurrence interval is the synonym, another name of the return period or frequency or time period, another name time period. So 25 years is the recurrence interval. They have given that it is 50 years. Option A is obviously wrong. Clear? Directly. Now, probability of flood occurring exactly 2 times. We have already seen some equation in transportation also, some probability that was for Poisson distribution. Okay, remember that. Here it is rainfall data. Probability of the flood occurring exactly 2 times in the next. Okay, how can we calculate probability of an event occurring r times in n years is nothing but NCR P raised to R Q raised to n minus R. Hope you know permutation and combination. It is very important for general aptitude. Okay, NCR and NPR permutation. Here they are asking the probability of flood occurring exactly 2 times in the next 10 years. How can we substitute then? 10C2 P we have to calculate. So how can we calculate P? What is P? Probability of occurrence. Very, very important formula. P is equal to reciprocal of recurrence interval or reciprocal of return period T. Okay, this is very, very important. You should note down. So P will be 1 by 25. Now we can substitute here 1 by 25 raised to 2. What is this Q? This thing is very basic. We have studied so many times before also. Q is nothing but 1 minus P, 24 by 25. No need to calculate what is the decimal value. Okay, simply you substitute 24 by 25. N minus R. What is N minus R? 10 minus 2, nothing but 8. Okay, so how to calculate 10C2? I don't remember whether it is available in online Calci or not. Okay, might be available. Calculate and tell me how much it will be. I'm not getting the, okay, I'm not getting online Calci right now to show you. Please tell me. 10 into 9 divided by 2 will come. Please calculate and tell me how much you are getting this. 10C2, 1 by 25 square, 24 by 25 raised to 8. How much you are getting? Okay, not available in online Calci. Then you should understand how to calculate it. 10C2 is equal to 10 into 9 divided by 2 into 1. Okay, so finally if you are calculating how much you are going to get, .0, yeah, this will be how much? 90 divided by 2, 45. Okay, if it was 10P2, if it was permutation, then only this numerator will come, denominator will not be there. If it is combination, 10 into 9, how many times, I mean, if you are simply doing n factorial divided by r factorial, okay, finally you are going to get like this. So 45 into that, how much you are getting? Yes, 0.05, 1 second, 19, enough? All are getting same? Yes, that is equal to whatever you are getting in decimals. So that is equal to 5.19%. Clear? Yes, very good, very good. Yes, all are giving the same answer, very good. Sorry for not mentioning your names, okay? Because once we started mentioning the names, then I cannot miss anyone, that's why. So whether the option is correct, they have given 10.4. No, absolutely wrong. Okay, we got the answer as 5.2. Now, see, by mistake, if you are not doing this divided by 2, how much you are going to get? If you are taking, instead of 10C2, if you are taking 10P2 or 10 into 9, how much you know? How much you are going to get? You are going to get approximately 10.4. Understanding? Purposefully, I have made that option. This is what I told you. In case if you made any mistake, here, instead of taking divide by 2, you are going to get 10.4 approximately. When you are looking at the options, you may be seeing the same data there. You may be thinking that, okay, your answer is correct. Okay, you have to prepare with that situation. Something you are getting in the calculation, you are seeing the same option there, doesn't mean that it may be correct. Okay, they will purposefully, they will make calculations like this and put it in the option. You have to prepare. Okay, this dangerous things can appear. Okay, I can tell it may appear. Okay, so yes, very good. As an intelligent students, you should prepare with that. Something you are getting in the option doesn't mean that your answer is correct. Now, what about the third one? Hydraulic risk in 15 years. What is the meaning of hydraulic risk? Very important. Hydraulic risk means, suppose tsunami is happening once. Is it a risk for us? Obviously, yes. Tsunami is happening 2 times. Is it a risk? Obviously yes. 3 times? Obviously yes. Tsunami is not at all happening. Then it is good. So risk means what? Anything. Either it can happen once or 2 times or 3 times or 4 times, whatever. Which means P of number of occurrences can be 1 or 2 or 3 or 4. It can be any times. So can I write it as 1 minus P of R equal to 0? Yes. Then what is P of R equal to 0? What is P of R equal to 0? NC 0, P raised to 0, Q raised to N minus 0. How much is NC 0? That is 1. P raised to 0 is 1. Anything raised to 0 is 1. Q raised to N. Understood? So P of R equal to 0 is nothing but Q raised to N. So what I can write? Hydraulic risk is equal to Q raised to N. What is this N? In how many years? Okay. Now, what they have asked? Hydraulic risk of the flood in the next 15 years. How can we calculate then? Risk in 15 years. How can we calculate? Q raised to 15. How much is our Q? 24 by 25. They are asking for 15 years. How much we are going to get? Yes, very good. 0.4579. Thanks for answering. So how much this is? 45.79%. Very good. So is it correct? 45.8? Yes. Option C is correct, na? Very good. Hydraulic risk? Yes, very good. Yes, Yogesh is telling at least once. Yes, very good. The same thing they can ask it as probability of occurring at least once. Very good. Another way of asking question. Probability of at least once. Okay. So option C is correct. Very good. So should I check option D? It is an MSQ question. So at least 2 should be correct now. Should I check option D? Very good. We have already explained that in transportation engineering session. Sometimes only one also can be correct. So we should check all the given options. Okay. So probability that the flood will not occur at all in the next 6 years. What is the meaning of that? Will not occur at all means R is equal to 0. Then what will be the equation? We have already seen. We have already seen that R equal to 0. Nothing but Q raised to N. Oh, sorry. Here I made a mistake in the equation. So 1 minus Q raised to N. Yeah, sorry. 1 minus Q raised to N. The answer is correct. But while writing, I missed that 1 minus. Okay, thank you. Okay, thanks for noting. Okay, answer is correct. 0.4579. If you are calculating the second part, you will be getting the other portion, 0.64 something. Right? So here 24 by 25 raised to, for how many years they are asking? Not at all occurring for 6 years. So probability of not at all occurring, we have already seen that it is equal to Q raised to N. So 24 by 25. How much you are getting, guys? Everyone please comment. 78, okay, 78 point. Please tell me the accurate value. Yes, thank you. So what is the given option they have given? 21.7. Absolutely wrong. If I am taking by mistake 1 minus Q raised to N, then I will be getting that answer, no? 21 point something. Yes, purposefully I have made that option. Clear? 78.27. Yes. So whether option D is correct or not? Absolutely not. So here the only correct option will be option C. Right? All are getting? Is it clear, everyone? Very good. Okay. So hydraulic risk, they can also ask you probability of occurring at least once. Okay. Or probability of exceedance, like that also they can ask. That also you can note down. Probability of exceedance. What do you mean exceedance? Exceedance means that particular magnitude is exceeding. Means tsunami is occurring, like that. To occur tsunami, we should have that much intensity, that much magnitude. So probability of exceedance, probability of exceedance means that magnitude is exceeding, so occurring at least once. Clear? Yes. So that point also you can note down. Right. So clear now? High chance of asking here. Now, yes, before going into the next topic, let me tell you regarding hyetograph and mass curve and all. So what do you mean by this hyetograph? Our next topic. What do you mean by this hyetograph? Nothing but a graph between, on the y-axis we have intensity of rainfall, and on the x-axis we have time. Okay, intensity and time. In the sense, suppose if we have a graph like this with intensity on the y-axis, what do you mean by intensity? In each hour, how much rainfall? We can either put it in mm per hour or centimeter per hour or mm per second. It's up to us. Suppose here we are putting in hour. Then if we have, suppose like this, some bar diagram, and each diagram indicates some intensities like this. For example, I am telling this is 10 mm per hour, this is 8 mm per hour, this is 9, this is 5. Okay. For example, simply not on the scale I'm drawing. Okay, let it be. I'm just changing the data. Let it be. This is somewhat 6, this is 7, this is 3. Okay. If I am asking you, time also I'm writing 0, 1, 2, 3, 4. If I'm asking you what is the total depth of rainfall in between or in the third hour, okay, what is the rainfall in the third hour? How can we calculate? What is the third hour? This is the first hour, second hour, third hour. Nothing but area of the hyetograph in that particular hour. So 3 mm per hour into 1 hour, 3 mm. Simply if I am asking you what is the total depth of rainfall, everyone please tell me. What is the total depth of rainfall in millimeters? Everyone please calculate and tell me. What is the total depth of rainfall in millimeters? How to calculate? Area under hyetograph. Okay. So area under hyetograph is the depth of rainfall. Hyetograph is intensity versus time. So if I am simply putting mm per hour, multiply with hour and hour will get cancels. We are getting some unit of depth. So that also can be asked for MSQ type of question. Which of the following statements are true? Okay. Area under hyetograph gives the, or we can tell that rainfall hyetograph. Okay. Area under rainfall hyetograph, or by default hyetograph means rainfall hyetograph. Nothing but the depth of rainfall. What it will be then? 10 mm per hour into 1 hour, 10 mm plus 6 mm per hour into 1 hour, 6 mm, like that. Okay. So what will be getting? 10 plus 10, 26. Correct? Yes, thank you. Understood now? This is nothing but hyetograph. Now, the next one is mass curve. What do you mean by mass curve? Nothing but if you are taking the cumulative depth of rainfall. Suppose this, I'm putting it as mass curve heading here. This is nothing but cumulative depth. What do you mean by cumulative depth? Nothing but we are keep on adding with the previous one. So this is time in hour. If we are taking the same example, in the first data we have, or in the first hour we have 10 mm. Now in the second hour what we have? How much total rainfall we have in the second hour? We are getting an additional 6 mm. So totally it will become 16. 10 plus 6 it will be. So it's going to be in the second hour we have 16. In the third hour we have getting 3 extra. We are getting 19. In the last hour we are getting 17 extra. Sorry, 7 extra. So total it is going to be 26. Understanding? Sometimes they can simply give a graph like this. Instead of giving you bar diagram and all, they can simply like this. They can give something like this. So always a mass curve will be either a constant or increasing. It will not come down. If no extra rainfall is happening, then the mass curve will go straight and a constant value. Extra is nothing. Is it clear, guys? What is the difference between a hyetograph and a mass curve? Is it clear? What is the difference between a hyetograph and mass curve? Everyone, please comment yes or no. Yes, very good. So what is more important for us? In case if they are giving a mass curve, from that we have to understand what is happening in each hour. Because in many questions, we require that. Do one thing, I told you to watch the video which I have done in the last year. You know? So there I have done a question where I have used this mass curve also inside the question. Okay. Instead of giving in each hour what is the value, instead of giving that, I have used the concept of mass curve and made a question. Okay. That video also you can watch for solving more number of questions. I hope it is clear what is hyetograph and mass curve. After some time, we are going to study another hyetograph, which is nothing but effective rainfall hyetograph. Okay. So this is rainfall hyetograph. By default, hyetograph means rainfall hyetograph only. After some time, we are going to study effective rainfall hyetograph. Okay. So there we are going to study area under effective rainfall hyetograph is equal to runoff depth. Here, area under rainfall hyetograph is rainfall depth. Okay. So that is a very minute point you have to note down. Can be asked for MSQ. Which of the following statements are true or false, like that. Okay. So that are the important points. Okay. Yes, very good. Above Horton's curve, we are going to study that. Yes, very good. So that are the important points you have to study under precipitation chapter. If you have any doubt, definitely you can ask me during the session or at the end of the session, or in the comment box also you can ask once the video is getting uploaded in the channel. Okay. Now we are moving into another important concept from hydrology, from evaporation portion. Just read the question and understand what they have given. Whenever they are asking, so this question is related to water budget method. So water budget method, whenever they are asking, the data will be very lengthy. Don't think that the solution is very lengthy. Solution will be very simple, but data will be lengthy. Okay. So by looking at the question, don't simply skip the question and go to the other question in the examination hall. Particularly in particularly in irrigation and hydrology, question length will be too much, but answer will be, solution steps will be very less. Okay. So properly read the question, take down the data. Very easy. Related to water budget method. Inside this, I have used pan evaporation method also. So two topics I have combined into one question. So properly read and take down the data. If you have noted down the data, please let me know so that I can simply explain something. Surface area is given, that is first data. Water level is given. Then rainfall depth, third data. Some water we have taken out, fourth data. Then class A pan we have used, Indian standard class A pan. Pan evaporation is given, next data. Surface runoff is given. That's it. Seepage loss is negligible. They are asking the final water level. Yes, hope you have taken down all the data. Right? Yes. Now see, I'm just explaining something. Whenever you are seeing precipitation, runoff, water taken out, seepage, final water level, initial water level and all, what we need to think about? Nothing but sigma inflow into a reservoir or into a lake or into any water course minus sigma outflow will give us the change in water level. The change in water level in the water course can be positive or negative. If inflow value are more, water level will increase. If outflow values are more, then water level will decrease. So properly you have to put plus or minus sign in the water level. What are the inflow values? Nothing but the precipitation and runoff. precipitation and runoff will contribute into the water storage. And what are the outflow? If evaporation is happening, water will lose from the reservoir. And if we are taking water for irrigation purpose or electricity production purpose, then also water level will decrease. So water we are taking out. Plus, if seepage is happening, then also the storage in the reservoir will decrease. So these three are the portions which are reducing the water level in the reservoir or water course, and precipitation and runoff are contributing. That is equal to change in water level is nothing but, always remember, final water level minus initial. Don't take initial minus final, then you are going to get the opposite answer. I mean, plus or minus will change. That is very important for us. Now take down the data. What is the precipitation given in the question? Directly given as 210 millimeters. Now see guys, very important. Once you are substituting the data in millimeter, all the data should be in mm. Once you are substituting in centimeter, all the data should be in centimeter, and so on. Okay. Simply I am putting in mm as of now. If you want to put it in meter cube or meter or centimeter, it's completely up to you. You can put. Okay. Later we can convert. Plus runoff value, what they have given? 0.2 meter cube per second. If I am substituting like this, can I add this? Obviously no. Then what we have to do? That value we have to convert into millimeters. If I am substituting in millimeters. So runoff value they have given 0.2 meter cube per second. How can we convert this into? Very good. I already started getting answer. Very good. How can we convert this into millimeter? First of all, this is a discharge rate. First of all, we have to eliminate that seconds and make it into meter cube. Then that meter cube we can divide it with the area, then make it into meter. Then we can multiply with 1000 and make it into millimeters. Clear? Whenever they are getting discharge, how can we convert? 0.2 meter cube in 1 second. Then what they have given? In January month. How many seconds are there in January month? How many seconds are there in January month? We know in 1 day or in 1 minute we have 60 seconds. In 1 minute, in 1 hour, then in 1 day. Multiply with 60, we are getting per minute. Multiplying with again 60, we are getting in 1 hour. Then in 1 day, again multiply with 24. In January month, how many days we have? 31 days. So this much meter cube we are getting. Now we have to convert into depth term. How can we convert? Dividing with the surface area. What is the value of surface area? 130 hectare. Should I convert into any form? Should I convert? Obviously we have to convert into meter square. Then only meter cube and meter square will get cancelled. So that is the next point you have to remember. 1 hectare is equal to 10 raised to 4 meter square, or 1 kilometer square is equal to 100 hectare. Those points you should remember. We are going to discuss this in detail in irrigation also. First chapter, very important. So 130 into 10 raised to 6 meter square. Okay. So how much you are getting? Everyone, can you please comment how much you are getting runoff? How much mm? So 0.412 something you are getting now, meter. So that is equal to 412 point. So do one thing, we are making in millimeters now. So make it accurate. 412.06 millimeters. At least 1 decimal or 2 decimal. 412. Yes. Okay. Thank you. So I'm putting 412 here. That will be there. Okay. 2 decimals I'm keeping. Minus. How much is evaporation, guys? They have given 80 mm now. So can I take 80 mm? Is it correct? Can I take 80 mm here? Vishal, I will come to that. Don't worry. Can I take 80 mm? Very good. This is wrong. Why this is wrong? That 80 mm is given as pan evaporation. Okay. So how can we calculate evaporation from the water course using the pan evaporation? Very important. Pan evaporation multiply with coefficient of pan is equal to evaporation from the water course. Very, very important. But more important point is whenever we are writing this equation, this should be in terms of depth. Okay, it is not in meter cube. It is not in meter cube per second. It should be in terms of depth of evaporation. Okay, so pan evaporation is given as 80 mm. We have to multiply with the coefficient to get the evaporation from this particular reservoir. But do you know what is this coefficient of pan? Whether they have given anything in the question? Whether they have given anything in the question? Very good. They have not given, but they have given that it is Indian Standard Class A pan. See, for GATE examination, they may be giving, definitely they will give this coefficient of pan in the question itself. Simply just going into the next level, I have not given. Remember at least this one. The Indian Standard Class A pan is having a coefficient of 0.8. One extra point I can tell you, we can change this coefficient of pan and make it as more than 1 only for this Class A pan. We have so many other pans also. USWB pan and floating pan we have, and the United States Weather Bureau Class A pan we have. So many Class A pans we have. We don't have to study everything. In case if they are giving in the question some other pan, they will give in the question itself what is the CP, coefficient of pan value also. At least you can remember Indian Standard Class A pan is having a coefficient of pan equal to 0.8. So how much is our E value? 0.8 into 80 mm, 64 millimeters. Clear, guys? Yes, very good. I'm already getting the answer. Very good. So E value we have to substitute as 64 here. How much value we have taken out? In the question they have given that 2.5 into 10 raised to 6 meter cube. Okay, they have given in terms of volume directly. Water taken out is equal to 2.5 into, sorry, how much they have given? 2.5 into 10 raised to 6. Do one thing, just make it as 2.5 into 10 raised to 5 because otherwise I cannot check your calculation. Please make it 10 raised to 5. Okay, 2.5 into 10 raised to 5. Then only I can check your calculation because I have the final data. All the options I made accordingly only. Make it 2.5 into 10 raised to 5 meter cube. Okay. So if you are doing 2.5 into 10 raised to 5 meter cube, 130 into same procedure. Okay. How much you are going to get? Let me also verify. 1 second, please hold on. Let me verify that whether it is 5 or 6. Sorry. Answer is same only. Since I am getting a comment here, that's why I told. Here it is 10 raised to 4, but answer is same. Okay, by mistake I have written for there. Here also 4. 1 second, guys. Let me confirm that. Yes, correct only. So just make it 10 raised to 5 only. 2.5 into 10 raised to 5. Okay. So we are going to get 0.1923 meter. That is equal to 192.3 mm. Henna, clear? Yes, very good. Okay. So substitute there 192.3 millimeters. They have given seepage is negligible. Okay, no need to take anything there. Yes, very good. So that is equal to what will be, what level they have given? Starting, at the starting of the reserve, starting of the month, means initial level they have given 405.2. So final water level we don't know. That is what we have to calculate. Initial level is 405.2 meters. So let it be there in meters. How can we calculate this? We have to convert that into millimeter. Okay. Either you can put 405,200, keep it there, or you can just calculate this left hand side, then convert into meter. It's up to us. Okay. So if you are calculating, what you will be getting? 210 plus 412.06 minus 64 plus 192.307. Okay, is equal to, yes. So how can you calculate this? Final water level minus initial water level will be, can you calculate this and tell me what is this value? Can you calculate this left hand side and tell me, are you getting 365.7 something? Can you please calculate and tell me? Are you getting 365 point? I just want to confirm my answer also. Are you getting this on the left hand side? Millimeters in terms of millimeter. I can also write like this. Yes, okay, thank you. Okay, so using this you can calculate the final. Final water level will be what? 405,200 will go that side plus 365.753. Yes, 405,565.75. Like that are you getting? Yes, very good. We need it in meters. So 405.565 meters. Or you can convert, just make it this into meters. Okay, it's completely up to you. Only thing is proper conversion should be there. That's all. Very good. Are you getting the same answer? 405.565. Which option it is? Option D, na? Yes, very good. Are you getting option D? Please compare my answer with your answer. Sure that you are getting the same. Yes, very good. Getting everyone? Yes, that's it. So only thing you have to note down is, whenever you are substituting, all the things should be same. Unit, okay? Unit should be same. Sometimes they can give in meter cube, or see, they can ask in what is the change in water level in meter cube. Like that they can ask. Only thing is to convert in between meters or depth term and the volume term is, we just have to use the surface area. Multiply with surface area to get it into volume term. Okay, divide with surface area to get it in depth term. That's all. The next point you have to remember is this: if they are giving pan evaporation, properly multiply with CP value and make it into evaporation from the reservoir or lake, whatever it is, and which month they are giving. Okay, they will not give you February month and all. Okay, don't confuse whether we should take 28 or 29 and all. They are not going to make like that. Okay, either they can give the number of days or they can give in a week. Okay, then no need to give which month it is. If they are giving in a week, just multiply with 7. Okay, as simple as that. Is it clear, guys? Yes, very good. All are getting D? Anyone not getting D? Properly check the calculation, conversion and everything. And this also, okay, hectare into meter square conversion, 10⁴. Okay. Hope you understood. So shall we go to the next question then? Okay, so before going into the next chapter, these are actually unimportant. The energy balance method and all. How can we calculate the evaporation using energy balance method? The rate of evaporation E is equal to solar radiation energy R divided by density of water into latent heat of vaporization. If they are asking the question, they will directly give you everything. R stands for solar radiation energy. In watt per meter square they will give. Gamma W is nothing but density of water. If nothing is given, we can assume 10⁵ kilogram per meter cube. L stands for latent heat of vaporization. They will give in the question. We have to substitute in joule per kilogram. So once you are substituting all this data, you will be getting the value of E in meter per second. Nothing but rate of evaporation. So if they are asking per month or per week and all, properly you have to convert into multiply with that time and you will be getting in meters. Understood? So rate of evaporation is equal to solar radiation divided by gamma W into latent heat of vaporization. If they are asking, they will give you all the data directly. Till now, they have not asked any question. If they are asking, just keep that in mind. Okay. One more data I can give you. How to control the evaporation. They can ask you for 1 mark purpose. We can use many many methods, like we can use some mechanical covers. Okay. And we can just cover using something by what we finally has to do, the reduce the area under the sunlight, you know, area under exposure, so that evaporation will decrease. But practically it is very difficult. So what we will do, we are going to add two inert materials or inert chemicals, which are nothing but cetyl alcohol and stearyl alcohol. This cetyl alcohol is also known as hexadecanol, and stearyl alcohol is also known as octadecanol. Okay, so these points you can remember. Cetyl alcohol is widely used. So these are what actually some chemicals which are inert chemicals, which will make a layer on the surface of the water course, so that it will reduce the effect of sunlight exposure on the water, so that evaporation will get reduced. Okay, suppose in case if something is happening on the water, maybe some kingfisher and all is coming and hitting the water, then this layer will break, but slowly that water will that layer will again will come and join. It will not affect our quality of the water. It's an inert chemical. Okay, you can remember these two, cetyl alcohol and stearyl alcohol, which we are going to use to control the evaporation. Okay, can be asked for 1 mark. Yes, very good. Okay, that's it. So that are the points you have to study under evaporation. One more point I can tell you regarding evapotranspiration. What is this evapotranspiration? Evapotranspiration, I will tell this in irrigation also. Evapotranspiration sometimes we use as a synonym of consumptive use. Actually speaking, consumptive use and evaporation are little bit different. The energy which we are using for photosynthesis and all will come. But in general, evapotranspiration and consumptive use of water can be tell as synonyms. What is actually evapotranspiration? It's a combination of evaporation plus transpiration in the vicinity of a particular crop. We have actual evapotranspiration, nothing but the evapotranspiration happening actually at a place. That's it. Whenever this actual evapotranspiration attains its maximum value, whenever the moisture content is becoming equal to the field capacity, what will happen? This actual evapotranspiration will attain its maximum value. That maximum value of actual evapotranspiration AET, we call it as potential evapotranspiration. Actual evapotranspiration stands for, sorry, AET stands for actual evapotranspiration. It happens at any moisture content. Okay. Potential evapotranspiration means the maximum value of actual evapotranspiration. And when it is going to happen, whenever the moisture content or the water content of the soil is becoming equal to field capacity of the soil. So whenever the moisture content equal to field capacity, AET will become equal to PET. So previous gate question, what is the range of the ratio AET by PET? We know AET can be 0 whenever moisture content is equal to, remember that, permanent wilting point. Whenever moisture content is equal to permanent wilting point or less than permanent wilting point. Okay, whenever moisture content, so here also we can put greater than or equal to field capacity. Okay, AET can be 0 and it can become finally AET become equal to PET whenever the moisture content is equal to field capacity, then AET by PET ratio will become 1. So previous gate question for 1 mark, the ratio of AET to PET. Clear? Clear? Yes. So that are the points you have to study under evaporation. Okay. Now we are moving into infiltration portion. Yes. Read the question which is related to Horton's infiltration curve. Just read the question and start solving the question. Everyone. Very important topic, Horton's infiltration. Whenever you are solving, meanwhile I will just draw what is Horton's infiltration curve. Hope you already know it. Horton's infiltration curve is actually a graph between rate of infiltration and time. Okay. So y-axis stands for rate of infiltration. The initial rate of infiltration, if I am denoting it as F naught, hope you are able to read it. It's F naught. Okay. And the final infiltration rate, I'm putting it as FC. Finally, after a particular time, the rate of infiltration will go on constant. We are putting it as FC. So what Horton has told, if you are taking the area under Horton's curve, means this portion. If you are taking the area under Horton's curve between any two time, for example, if I am telling this is T0 and this is maybe T1 or Tn, anything. If we want to calculate the infiltration depth between T0 and T1, what we need to do? Between that time, we need to take the area under Horton's curve. So how can we calculate the area under Horton's curve? Integrate it. Okay, previously we have studied area under Hyetograph. Then we are going to get depth of rainfall. Here, area under Horton's curve, since y-axis is rate of infiltration, we are going to get depth of infiltration. But here we don't have a regular shape like square and all. So we have to integrate the equation. What is the equation of a Horton's curve? Fc plus F naught minus Fc into e raised to minus kt into dt. We can put the first one. Okay, if I'm putting T1, T2, lower limit and upper limit, T1 to T2. Clear, guys? Okay. Now, the very important point we have to remember here. So this is the depth of infiltration, but we have to note down whenever we are integrating, the intensity of rainfall should be always above this Horton's curve. See, when infiltration will happen, we should have rainfall also. Without rainfall, we will not be having infiltration. So the intensity of rainfall or the rate of precipitation, rate of rainfall, nothing but intensity of rainfall. That should be always above this rate of infiltration or above the Horton's curve. Then only we can directly integrate. If the rate of infiltration is less than, if the rate of rainfall or intensity of rainfall is less than the Horton's curve, then what we have to do? We have to properly check in what portion it is intersecting. For example, if I am telling you the intensity of rainfall is something like this. Okay, uniform intensity, suppose like this. Okay, intensity of rainfall is like this. Then if we have to calculate, the infiltration depth, then what we need to do? We have to select the portion below this curve only. Means this portion, this portion which is above the intensity will not contribute. Yes, that portion will not contribute any runoff. One second, I'm just drawing that again. Yes, if I want to calculate the runoff value, if I want to calculate the runoff value, only this portion will produce runoff, and whatever portion I have shaded, in this portion actually what is happening, the intensity of rainfall is less than the intensity of rainfall is less than the rate of infiltration. So that what will happen in this portion? If anyone is having problem with that visibility, since I'm getting the comment, I'm sorry, I'm unable to maximize that size. Okay, hope you are understanding what I'm telling. If the intensity of rainfall is less than the rate of infiltration, what will happen? Whatever intensity of rainfall is happening, all the water will go into infiltration. So runoff will not be producing. Okay, that's what you should have to remember. Only this blue portion will corresponds to the runoff value. Okay, we can understand using this particular given data. What is that? Then I can draw the large figure. Okay, then you will understand. Don't worry. So what is the given data? So something like this. They have given the initial infiltration 10, final infiltration 3. Properly listen, it is centimeter per hour. That is also very important. Finally, they have given that it is 3. Clear? Yes, very good. And what is given in the question? Intensity of rainfall is 4.8. Yes, this is what I told. Throughout they have given that intensity of rainfall is 4.8. So how it will come? Intensity will come something like this. Throughout it is 4.8. I'm not marking everywhere. Something like this. This is nothing but the intensity. Clear? Is it clear, everyone? Now where we will be getting the runoff then? Where will be getting the runoff then? Which portion will create runoff? Which portion will create runoff? Yes, very good, very good. After intersection means only this portion will create runoff. How can we select that? They told that rainfall is happening for 6 hours, but we have to calculate the runoff produced in 4 hours. So 0 here, somewhere we have 4. Okay, let it be there. Okay, can I simply integrate from 0 to 4? Can I simply integrate from 0 to 4? That's what we told. No, because in that particular duration here, there is no runoff will producing. There will not be any runoff producing. Yes, very good. We have to select or we have to check what is this particular time. Guys, are you following me? Are you able to understand what I'm telling? So this time we have to find and we have to integrate what is that particular time t. If I'm putting somewhat t1 to 4, then fc plus f naught c into minus kt dt. Are you following? Everyone please comment. Are you following me? Yes, thank you. Okay, very good. So how can we calculate that time? How can we calculate at what time we are getting an intensity of 4.8? We can use the Horton's equation. What is Horton's equation? Infiltration at any time t is equal to fc plus f naught minus fc into e raised to minus kt. That is the Horton's equation. That is what we are integrating. Then we got that value we are substituting here. 4.8 is equal to fc is 3 into e raised to minus, what is k? Horton's constant, given that 0.6 per hour. So 0.6 into t. All data is available, only unknown is t. So once you are solving t, how much you will be getting? 4.8 is equal to, please solve it, 1 second. Yes, how much you are getting? 4.8 is equal to 3 plus 7 into e raised to minus 60. We will be getting t is equal to 2.2635. Are you getting t equal to 2.2635? Are you getting, everyone? Yes, if you are getting any confusion, how to calculate it actually? 4.8 is equal to 3 plus 7 into e raised to minus 0.60. So 3 will come in this side. So 1.8 is equal to, so 1.8 by 7 is equal to e raised to minus 0.60. If you want to take that exponential out, what you have to do? Take the natural logarithm on both sides. Is equal to ln e raised to minus 0.60. If you take the natural logarithm, that is equal to minus 0.60. You will be getting like this. So calculate what is natural logarithm 1.8 by 7. Then take divided by minus 6. You will be getting t is equal to, okay, if anyone is having any problem. Clear, guys? Okay. Yes, very good. Now what we can do? Now you integrate. Now you integrate what you are getting. 0.26. Is it 2.2 or 0.26? 2.2, no? Yes. Yes, okay, thank you. 2.2635. Upper limit is 4. So 3 plus 7 into e raised to minus 0.60. So integrate it. I hope you know what is integrate. I mean, how to do integration properly. So 3t limits will come 4 and 2.2635. Only thing is properly you have to do in the online calculator. You can do it separately and note down the value. Very important. Don't forget to put minus 0.6 here. Once you are calculating how much you are getting, those who have already done the calculation, please let me know. I am getting 7.151. Please tell me whether my calculation is correct or not. Please let me know whether my calculation is correct or not. You may take some time. No issue. While solving question, it will become fast. This F calculation I am telling. Are you getting the F calculation as 7.151? Yes, 7.16. Yes, no issue. 7.1516. At least 7.1 around if you are getting, that will be correct. Thank you, Krishna. Anyone else? Sign then check your calculation again. Yes? Okay, very good. You can just check your calculation later. No need to waste your time. Now see what we get, what we are actually getting while doing this question. I mean while doing this step. Infiltration. What we want to calculate is runoff. How can we calculate? What we actually got? What we actually got is this shaded portion, area under Horton's curve from 2.26 time to 4. This is what we already got just now. But what we need to calculate is runoff. Runoff is this yellow portion. How can we calculate this runoff? Not till 4. Okay, I'm writing till here. Okay, let it be. Intensity of rainfall is again there till 6. Yes, very good. Okay, very good, very good. Okay, so how to calculate this then? How to calculate this runoff? Out of this total rainfall, this much portion below this Horton's curve is going as runoff. Now the remaining portion will come as runoff, precipitation minus infiltration. Now how can we calculate the precipitation then? Intensity into time. We have already seen that. What is intensity? 4.8 centimeter per hour. Then what is time? Very important. Don't simply put it as 4 hour and all. 4 minus 2.2635. Within that particular interval. Don't make mistake finally. Then how much you are going to get? Intensity will be around, are you getting 8.3352? Okay, thank you. 8.35 or 8.335. Around approximately 8.335. Okay, thank you. So everything is in centimeter we are substituting. So runoff will be 1.1842. So what is the value that you are going to substitute? What is the value you are going to substitute? Round off to integer. So what is the value you are going to substitute? 1 or 2? Or 1? Round off to integer it is. Look at the question. So what question you are going to type there? Are you going to type 1 or are you going to type 2? You can type either 1 or you can type either 2. No problem, because you are going to get 0 mark. Why? Very good. It is asking in mm. Properly note down. All the data is in centimeter, but they are asking in millimeters. Okay. Very, very important. The unit is very important in hydrology. Easily they can deviate you. So that is equal to 11.842 millimeters. Either you can put 11 or you can put 12, or they may giving you a range 10 to 13, 10 to 14, like that, some range they may give, because so many calculations are there. Okay, so properly look at the units in which they are asking. Very, very important. Is it clear, guys? Okay, see, this is somewhat, I can tell, level 3 question of infiltration. Most of the time they may directly give you the data, but this is somewhat the next level. Okay, always check whether the intensity of rainfall is more than the infiltration rate or not. If not, then properly we have to check where it is less than the infiltration rate. Okay, correspondingly you have to calculate that time. And for calculating the runoff, always take the portion which is above the Horton's curve. Okay, now see, guys, below Horton's curve we got infiltration. Above Horton's curve we are getting runoff. There is another name for this runoff. Many names are there for the runoff. Excess rainfall. Other name is effective rainfall. Other name is net rainfall or rainfall excess. All these are other names of runoff. So this portion which is above the Horton's curve, okay, this much portion is also known as effective rainfall hyetograph. This shaded portion is yellow shaded portion is also known as effective rainfall hyetograph. By default, hyetograph means rainfall hyetograph, which is of the rainfall depth. But this portion is indicating the runoff. So either we can call it as runoff hydrograph, but generally we call it as effective rainfall hyetograph. So 3 points. Area under hyetograph is runoff depth. Area under Horton's curve is infiltration. Area under effective rainfall hyetograph is runoff depth. Effective rainfall hyetograph means what? Portions above Horton's curve. Is it clear now? Yes, useful rainfall. Very good. Useful rainfall is another name. Useful rainfall is also they can use instead of runoff. Is it clear, guys? All are getting the answer? Clear now? Yes. So the time for this session is winding up. The remaining portion we can use in the next part. So now onwards, you got the basic idea of rainfall, of intensity, infiltration and everything. Now we can go a little bit fast. So in the next portion, in the next session, which is going to happen on the next day, same timing, we are going to study some phi index, W index, hydrograph, and the other portions also we'll see. Okay, since these are the basic portions, we have taken some time. This much time will not be required for the upcoming questions, which we are going to discuss in the next session, because these are the basics. Okay, fundamentals you should be properly understand, then only you will not make mistakes in the examination hall. Okay, so we are winding up this session. So thanks for joining. The next session of hydrology and irrigation will happen tomorrow on the same timing, 2:30 to 4:30. And for transportation engineering, we have already completed 2 parts. The third part will be most probably day after tomorrow. Do one thing, just subscribe the channel and click on the bell icon also, so that you will be getting that notification, or you keep on look at the channel for upcoming subjects and all, which all subjects are going to come. You will be getting that in the timetable. Okay. So that's it. So shall we wind up? So I hope all the portions which we have discussed under this session is clear. Very, very important is basics. Okay. If you have the basics, then whatever tough questions they are asking, you can easily solve it. Okay. Yes, once we are finishing the session, we will be giving you the PDF. Okay. Transportation, one more part is there. Once we are finishing up, we will be giving you similarly hydrology irrigation also. Don't worry if you have not taken the questions or any solution or anything. Right. So stay tuned with subscribing the channel. So thanks for joining and thanks for watching. We'll meet in the next session tomorrow, same time. Bye. Good day. So we are winding up this session. Take care.